Hi, Derek. Are you familiar with the Fibonacci series?
Yes, I am familiar with it.
Okay, so in Python, I want you to create a function that takes in an integer n. Your integer n will be a positive number, and I want it to return the nth value in the Fibonacci sequence. Do you think you can do that for me?
Yeah, I can do that. Can
Okay.
I assume that the function only receives positive values as input?
Yeah, only positive numbers.
Okay, so the Fibonacci n. So I'll create by defining the function, which we'll call it Fibonacci n, with n as our only argument, which will be the number of terms of the sequence to print. So for the Fibonacci sequence, the first two terms are given. They're 0 and 1 regardless, or at least for if n equals 0 or 1. So we can add in an if statement to check if our input is equal to 0 or 1. So in the case that it's 0, we know that the the term in the sequence is 0, so we can print that and return. And if n is equal to 1, we can print 1. That's another known condition and return. So in the case that our input is neither 0 or 1, we have to compute that nth term in the sequence. So we'll start by defining a couple of variables, num1 and num2, and we'll set these equal to 0 and 1, and these will be used to compute the nth term in the sequence. Next, we'll have a variable called count, which will help us keep track of how many terms of the sequence we've computed, and then we'll have next number, which will also be used as part of the sequence computation, and we'll initialize that to num2. So since I'm doing this iteratively, we'll use a while loop with our count variable, and we'll loop in while it's less than n to compute the nth term in the sequence. So we'll increment count, and then the formula for the Fibonacci sequence is Fn is equal to Fn minus 1 plus Fn minus 2. So to compute that, we'll use next number, which will be the next term in the sequence. Um,
Hey, sorry,
which
just
will,
stop you while you're coding. Do you think below this you can make a note of the Fibonacci sequence to your understanding? Just go up to
um,
maybe five values, five or six values.
yeah. So I'll do it above the function. So the values are the first four or like five terms are 0, 1, 1, 2, 3, and 5. Sorry, that's six terms. So that's the first six terms of the sequence. Um, should I keep going or
No, that's good.
okay? So yeah, going back to where we were. So so we have to implement the rest of the formula for computing the nth term in the sequence. So num1 will be our n minus 1, or the previous term in the sequence that was computed, and then we'll add that to num2, which will be our n minus 2, which will be the term before the previous term. And so I'll actually label this to the side just so we have a representation of what the formula is. So that's Fn minus 1 plus Fn minus 2. And then we'll have to set our values accordingly so that the next iteration of the loop, they're set up correctly. So we want our num1 to become our num2. So our n minus 1 becomes our n minus 2. And our next number, which is the current term of the sequence, becomes our n minus 1. So we'll set that to num2 and next number. And then finally, at the end of the loop, or sorry, outside the loop, once it's iterated the correct number of times, we'll want to print out next number, which will be our nth term in the sequence.
Okay. Are you done?
Yeah.
All right, so let's do a test case. So call this function and let's set our n to 3 and see what we get
Okay.
back.
Okay. So we'll call it Fibonacci n, and we'll add our parameter as 3. So I'll go ahead and run this.
And okay, works perfectly. All right, thank you, Derek.
All right, thank you for your time.